let's cover some principles that we can that can give us some base so we can cover those assumptions in more details. And one of them is about the cold formed steel and buckling. Right? So unlike hot rolled steel, I'm talking here about the universal beams, universal columns, the structural steel, or fabricated steel, as different people call it different ways. Cold formed is what we call thin walled. So as you know, the cold form is very thin. So the failure isn't just about stress, but about geometry. I don't want to overcomplicate here, but just follow this with me, and I think it's going to make sense. So buckling is one of the things we need to assess when you're doing cold formed steel. And what's buckling? It's a deformation of a structural component, such as a column or plate, under a compressive force. So here's a ruler I have, and it's very thin, as you can see. So if I apply a compression force, what's going to happen is this ruler is going to bend. Right? Can you see it's bending? So this is exactly the same thing that happens when we're doing the design of cold formed. It's very thin, so it bends. It doesn't need a lot of stress to bend. And there are different ways that this bending or this buckling can happen. One of them is local buckling. So as you can see here in this image, and local buckling is very tricky because it can actually happen over short periods, short lengths, even 60 centimeters long. So when you're talking about shed design, so to quickly open Shedmate here to go through this process with you, zoom in a little bit. So for example, local buckling could happen every 60 meters. So no matter the amount of fly bracing I put here, you know, we could still have a local buckling because it's every 60 centimeters. And we don't want to do bracing every 60, you know, or 600 millimeters. That's not, you know, practical whatsoever. So this is something that, you know, we assess when doing the analysis. The other one is distortional buckling, which is the cross-section shape changes through the rotation of flanges and webs. And then we also have the global buckling. That's where the entire member deforms without changing its cross-sectional shape. Once again, I don't want you to be very worried about the complicated terminology here. I just want you to understand that buckling exists, and this is what we assess very consciously when doing the design of these kind of buildings. Let's move forward because that gave us that base. So, okay, Arthur, you're talking about all of that BS of buckling. What does that mean for me? It means that this is why you need bracing. I've talked to some shed businesses who they don't like bracing at all. I know it can be a pain to erect, but if you don't have bracing, you need thicker materials. Remember, you need a thicker ruler so it doesn't do this, right? So this is the price you're paying. If you need a light design, you need bracing, right? So you need knee bracing, you need roof bracing, you need wall bracing, you need fly bracing, because the fly bracing, knee bracing, all of that is going to act as an item that's going to reduce the total length of that specific ruler. So now I need to put a lot more strength to actually bend it. But if I have the item there, just like a rafter, look, this could bend very easily. But when I add a fly bracing here, then, okay, it becomes harder to do it. So this is pretty much the principle around it, right? So an engineer will specify the bracing to reduce the buckling lengths, as we just discussed here on the ruler. So the length won't be the whole ruler, will be pretty much from here to here. So now it's a lot harder to buckle, to bend it. We're gonna do this to control sway and to satisfy code requirements. So in Shedmate, if you're using Shedmate as a designer, there are many ways to do this. So it's very simple. You know, when you come to the system, you go to structure, and then you can add fly bracings, you can add apex bracing, you can add knee bracing, or you can add all of them. And there are lots of rules you could use to pretty much how you want it to be. Like, do you skip the first purling set? What's the maximum spacing you want for them? For the knee bracing, for example, what's the distance from the fascia? What's the angle? Is there any offset? So as you can see here, I'm kind of making some changes, and Shedmate is reflecting those changes in the system there. I could flip it around. So there are lots of different configurations, and it's very easy to do because you're not modeling each of these as you do in AutoCAD. You're pretty much setting the configurations. That's why Shedmate is a configurator, and then Shedmate is going to apply all of that for you, and you can see the impact of that in real time. Okay, so let me just remove this here, and let's have that shed without any bracing. Let's go back to our discussion. So we understood the importance of bracing, and something else that can vary a lot is related to the connection. The connections are pretty much the way that we as engineers will specify how the interface of the column with the footings will happen. So there are lots of different types of supports. I'll just cover these two because they're the more popular ones. One is what we call the fixed support. So for fixed support, imagine that I have this ruler here and I am fixing this in a way that if I try to rotate this, it won't go. So when I do this, it creates some stress on my hand, which would be the footing, right? And this force times distance, that's what we call momentum. So that would create some momentum that creates some stress, some internal forces here on my footings. And then we have something that we call pinned support. So the pinned support, just imagine a pin. That's what I'm doing. I'm pinning it. So it still allows me to do this kind of movement. It won't create a lot of stress on the footings related to that momentum. However, I cannot go up and down because it's pinned. So this is the uplift and down lift that's happening here on my footings. So what's the consequence of these different types of footings? If I'm using a pinned support, then I might need stronger frames, but my footings might not be that big. And obviously, it depends. I'm just giving here generic example. And the pinned, because it has this kind of movement, it requires more bracing. So this is why when you're using bracket systems, we might need more bracing, and that's normal because this is not fixed. And the fixed, the loads are transferred to the column and footings, and in some cases you can have bigger footings and smaller frames. So there are lots of different designs out there in the market. So for example, this here for this RHS frame, as you can see, it's welded and it has a base plate with 4 bolts. So this is a lot stronger than this one here that's kind of pinned. And this column here is pretty much has the possibility of that movement. So when we define different connections, we need to define the assumption will change and the calculations will change as well. So if you're trying to compare a fixed connection with a pinned connection and you want the frames to match, well, you're trying to compare apples with bananas. So you need to understand that these will create different outcomes.